Before we begin today's presentation, there are a few housekeeping items that I'd like to address with you all. Today's presentation includes a slide deck along with screen share. Please note the quality of the screen share may be dependent on your bandwidth and connection speed. To ensure an optimal viewing experience, please ensure that you have checked system requirements along with bandwidth considerations. Viewing can also be enhanced by expanding your slide area either by clicking on the Maximize icon on the top right corner of the slide area or by dragging the bottom right corner of the slide area. If you encounter any technical difficulties during the broadcast, please click on the Help link located via the question mark widget at the bottom left of your screen, where you will find details about system requirements and frequently asked questions. We also suggest if you encounter difficulties during the screen share to refresh your browser in an attempt to resolve any buffering issues that may occur. To participate in the Q&A session at the end of today's presentation, please submit your questions via the Q&A widget and hit Submit. We'll answer as many questions as time allows. Also, notice the Learn More widget. Here, we've added a copy of today's slide presentation along with some additional content, including links to additional resources on our Topaz and Strobe solutions. We also encourage you all to fill out our survey before the end of today's presentation, and by submitting your response, you will automatically be entered to win a $50 American Express gift card. Once again, click on the Help link located via the question mark widget for help with technical difficulties. We are extremely pleased to have as our speakers today Compuware product managers Steve Kansa and Spencer Hallman and technical consultant Glenn Everitt. With that, I'd now like to welcome and hand things over to Steve.
Thanks, Janet. Before we get into the details on Java, I'd also like to update you on Compuware's innovation roadmap. Our roadmap is driven by 5 themes. For existing code, IP preservation to safeguard back-end processing and optimize existing business applications. For new code, IP advancement to extend existing business logic to support new projects for the digital economy. Across your portfolio, application understanding to help visualize your application portfolio, data, and relationships across your mainframe platform. Additionally, across the portfolio, balancing cost and performance to optimize operations and establish meaningful metrics to measure success. And throughout all our solutions, we're striving for simplicity in design and usability to make our solutions accessible for both experienced and new users to the mainframe platform. For those of you that are unaware of the pace of innovation at Compuware, at the beginning of the year, we moved to quarterly releases following an agile development lifecycle. We finished our 3rd quarterly release in July, and we're currently working on our 4th quarterly release for October. Our roadmap includes major enhancements in our existing solutions and the value for today work streams you can see in the roadmap delivery area, as well as innovative new capabilities in our Essential for Tomorrow work stream. Today we're going to be updating you on our Topaz for Java performance, which was released in July of this year. To cover some background, I'd also like to talk to you a bit on why Java on the mainframe makes sense. First, as you're probably aware, mainframe costs are largely driven by general CPU usages. Java, however, has the unique capability of being eligible for specialty processors with lower licensing costs. Specialty processors are also always run at full speed and aren't artificially constrained by vendor contracts. Additionally, the new Z13 hardware, there is multi-threaded support capability for improved throughput on the specialty engines. Additionally, Java has a massive community of developers and is, by some measures, the most popular language at the moment. Many newer developers entering the workforce today are more likely knowledgeable in Java and eager to work on Java versus older languages such as COBOL or Assembler. This makes Java a good fit for modernization on the platform. Lastly, Java has a unique advantage on the mainframe of being able to leverage future performance gains as new hardware and software becomes available from IBM. In the chart on the right, you can see the continued advancements that Java on the mainframe has made in terms of performance over the last several JDK and hardware revisions. For those of you that aren't as familiar with Java, there are several important areas to be aware of in implementing Java on ZOS. Java applications run inside a Java virtual machine, also called a JVM, which has its own configuration parameters. Java code is compiled to bytecode as the classes are about to be loaded for the first time. This can lead to performance problems when the application is first launched and newly accessed classes are being compiled for the first time. Java also handles the allocation and deallocation of memory automatically for a developer. This doesn't mean that memory management is any less important. The process of reclaiming unused memory, called garbage collection, has a performance impact on the application each time it's run. Additionally, exceeding the memory configured for a JVM in a mainframe environment can cause your JVM to be terminated by the operating system, which obviously is not a good situation. Additionally, unique to the mainframe platform, Java applications and their other mainframe components will be executed across both the mainframe's general CPU as well as specialty processors. It's important to understand these aspects to be able to understand the performance profile of your application on the mainframe. Lastly, Java doesn't prevent writing poorly performing code. It's just as important on Java to understand how your code will run in a test and a production environment and actively work to optimize its performance. All of these factors led us to create Topaz for Java Performance. It's important to understand why our solution is unique. Many mainframe performance tools often see a JVM as just another job in the system. They don't see inside the JVM to see what's actually happening within the Java code like our solution does. Many existing Java tools are also not mainframe-centric and thus might not account for the unique attributes of the platform. For example, running on the general processors versus the specialty processors in the actual monitoring process can result in high costs introduced by the monitoring itself. We specifically designed Topaz for Java to run fully on the specialty processors, thus minimizing the cost of the monitoring. Many existing monitoring tools are also designed to be 24/7 monitors for every transaction in the system. This can at times be overkill and cause performance and cost issues with the extreme high volume nature of many mainframe applications. Additionally, these tools aren't designed with batch processing in mind. We've designed our solution to work for both online applications as well as batch programs that don't have interactive components that other monitoring solutions might be expecting. Finally, many solutions do not inherently retain a history of monitoring and can't be automatically triggered, making them a challenge to leverage in production environments where you need them the most. To give a brief overview, Topaz for Java is a tool for both performance analysts and developers. The solution has an agent and a manager component that can reside in the mainframe and gathers metrics and also controls the performance monitoring process. Users can interact with both these components through an intuitive web-based interface, which can be accessed via any browser. Topaz provides analytics on the Java code inside the JVM and also attributes of the JVM to understand the performance of Java applications. The detailed CPU, thread, and memory analysis metrics it provides help with optimization efforts of the application. Additionally, it can be integrated with our Strobe solution for a complete picture of your application's performance across the mainframe and all of its components. Now that I've covered some background, I'm going to turn it over to Spencer and Glenn to give a brief solution demo.
Thanks, Steve. And I think that that last point that you brought up was a very good point, because a lot of times these Java performance tools only focus in on the JVM, whereas the Compuware solution is really allowing you to see what's happening outside the JVM as well as what's happening inside the JVM. And so what I'm going to do now is I'm going to share my screen. And what you're looking at is the Strobe Adviser report. So what I've done is I've gone out and I've kicked off a strobe measurement. It's went out there. It's measuring a WAS region. And when it started to measure the WAS region, it noticed that there was a Topaz for Java Performance agent loaded into the region as well. So it sent a command over to that agent to automatically start collecting the information within the JVM. So while Strobe is collecting all the activity in the address space, and we'll report on that, the Topaz agent is collecting the information within the JVM. So we really get the complete view of what's happening to our application. So what we're looking at, it's actually it's an IBM application called DayTrader. It's a demo application, and when we measured it and then created a profile, we're now looking at the Strobe Adviser. And the Strobe Adviser is Strobe's way of basically analyzing all the data in the profile for you and bringing that information back in a user-readable format, so the user then can identify what they should be working on. Now, you can see here that it says at the bottom, user application CPU. It says Strobe saw that there was almost a little over 14% of the CPU was in Java, and it's giving you a link here to jump to the Topaz for Java Performance. Alternatively, in the upper right-hand corner, there's another icon too that we could click on, and that would take us to the report as well. So I'm going to click on this. And that's going to bring me to the Topaz for Java Performance application. And this is where I get to hand it over to Glenn.
Thanks, Spencer.
To walk you through our latest products.
So as Spencer pointed out, we've kind of gotten the outside view of the JVM, and now we're going to go into the inside view of the JVM with the Topaz for Java Performance product. And what you're looking at here is the kind of the vital statistics of your JVM. We've got CPU time in the upper left. We've got heap memory allocations going on in the upper right. We've got the number of threads executing in the lower right. And then we've got classes in the lower left. So we're going to kind of march through these four panels here and talk about some of the data that's being presented. So in the CPU window, one of the things to first notice is that the CPU time is in milliseconds. And the reason why we did that is because we wanted to make sure that people understood that this is rather than most products will present this as a percent of utilization of the CPU. And we found that that wasn't particularly useful because, again, this CPU time includes both specialty engine time and general CPU time. So when you normalize that specialty engine time and add that with the general CPU time, that's the time we're representing. If we didn't do that, then you would have some perhaps throttled CPU time from the general CPU and some non-throttled time from the specialty engine, and you would be kind of mixing apples and oranges there. So by utilizing the time here, we get the total CPU time that you're looking at. If you look along the lower left axis, or the x-axis, what you're seeing is that the system was essentially idle. And then after about the first 10 minutes, we started cranking up our DayTrader application, driving it with a JMeter application to drive some serious traffic at this particular system. And then you're starting to see the CPU spike up. If you look down below there, almost directly below where you see those initial spikes, you'll start to see that the classes they jumped up from about 12,600 to about 14,350. Now, this is a WebSphere Liberty profile, which is the lightweight version of WebSphere. If this were a full WebSphere, the number of classes here would be significantly larger. So now we're going to kind of jump over and look at heap memory for just a bit and talk about that for a second or two. You see this very odd pattern in the heap memory allocation area, and we're going to expand that a bit so we can look in a little bit more detail. Before I do that, along the top there you see a line, and that blue line indicates the maximum heap size that is available for allocation. Now, in this particular case, you see a stair-step pattern where it's increasing. Now, this is a relatively dangerous thing to do. This means that no one set a maximum heap size in the Java parameters. And that's dangerous because it can continue allocating memory until you actually pass the memory that was allocated for the job. And in that case, you would actually cause a memory allocation event for this particular JVM job, which is not what you want. So it's recommended that you do go ahead and put a maximum heap memory allocation in there. And then in that case, you would see a flat blue line along the top there. Now, what this fuzzy pattern below here is the garbage collection memory allocation and deallocation. So what I'm going to do is I'm going to expand that to look at that in a little bit more detail. You see it's a zigzag pattern across the screen here. And what this represents is at the lower bottom here, and as we travel up to the right, what you're seeing there is the Java programs running inside of that JVM are allocating Java objects, and those things require memory. And so we're allocating that memory off for those objects off of the heap. And that heap then gets to a certain size where the JVM goes, oops, I'm a little bit concerned about memory. I better do some garbage collection. And it looks for all the old objects and gathers them up. And then we drop down to a lower level of memory usage at that point. So this gives you an idea of kind of the frequency at which these garbage collection processes are happening. So you can hover over these locations here and do a little bit of time comparison, and you can see how long it is approximately between these different garbage collections. And what will happen is if you do not really have enough memory allocated, these garbage collections will happen so frequently that basically your JVM will be spending all of its time doing nothing but garbage collection and very little activity related to getting your application work done. So it's good to take a look at this particular chart to understand how much memory is allocated and whether you have enough or garbage collection is happening so frequently that your application doesn't have time to get its work done. So let me scroll down just a bit here and we'll talk about threads report. Threads are the units of execution that do the actual work for your program. And so what you're seeing here is, oh, that's interesting. So let me go back to the original form here. There you go. And what you'll see now is that we've got some number of threads executing here. In fact, we've got about 88 threads when we start the application, and those threads probably weren't doing much until we ramped up the JMeter testing. And we peak out about 103 or 105 threads in this. So what we can do now is we can also take a look and see which threads are blocked. You see this red indicator line at the bottom, and that indicates the number of blocked threads. You see a little key there off to the right-hand side. So we're going to drill into the threads report to look at this in more detail. So the threads report shows us it gives us a view of the number of threads that are actually executing and whether they're in a runnable state or not. And one of the things I like to look at as we go through this is I like to look at the time that was spent with threads being blocked. So again, that's a big performance thing. And a blocked thread is caused when you have multiple threads trying to access the same shared object. And that could be a memory location, or that could be a timer or something along those lines. And so if those things aren't available, then a particular thread has to sit and wait for that. And then you end up where your block time can go up. In this particular case, it looks like we're and that top, or the thread that's waiting the longest, we're about 2.5 seconds. So that's not too bad. So we're in not too bad a shape with this particular situation. And the next two threads down had a minimal amount of blocking also. So that means that we're in pretty good shape with this. But it's a good idea that those numbers are larger, then you need to investigate and look at what the blocked thread, what is causing your thread to be blocked. And again, that's probably something that's a shared memory object. It's typically the issue that you'll have. So now I'm going to bounce back up here, and we're going to go back and we'll look at the classes section here next. So in the classes area, you'll see that we initially started out with about 12,600 classes loaded, and it looks like we peak about 14,350 classes. Now, when you start looking for performance bottlenecks, you certainly don't want to have to look through 14,350 different classes to figure out where your performance bottleneck is. So what we've done here is we can drill into this chart, and it'll take us down and it'll show us basically a set of methods that were executed. And we're a sampling type of monitor, so as we're sampling, we look to see which methods are on the stack when we're making those sampling calls. And then based on that, we look at we estimate the amount of time that particular method was spent executing. So in this particular case, you'll see that we've got some things, I've got these sorted by the percentage of time that they spent executing, and you can see the number of observations that we made and what happened there. So I'm going to jump over to this other window where I've got a particular one of these call stacks open so that we can take a look at it and understand what it's doing. So as I went through and drilled down through this particular call stack, you'll see it's quite deep. And you'll see that, again, this is our day trader application. Let me do a quick find here so that it highlights it, and I think it'll be a bit easier to see. So as we look at this call stack, you'll see that there's method, calling method, calling method, calling method. So we'll kind of start at the bottom and work our way up pretty quickly. So inside of your WebSphere Liberty application server, what you see here is these threads are being executed, and this particular thread is a web application thread, and it's launching a particular application execution method. And what you're seeing here is that we're looking at the orders alert filter, and that turns around and gets the closed orders. So as we march up this application stack, what you're seeing is that we're basically turning around and doing a query to find out what our orders were that got closed. And as we march up, we start to see JDBC calls, and we march up a little higher, and there's more JDBC calls, and we march up even further, and we start to see references to GB2. And it looks as though, based on what we're seeing here, is that someone is, in this day trader application, is making JDBC calls to a DB2 to do a query, and that query is using a Type 4 driver, which is a Java JDBC driver. And probably what you want to do is use a Type 2 driver, which would be a native code driver. Now, again, this is shows a nice inside versus outside view. Now, Strobe would be able to show you the native code driver and what its performance is, whereas Topaz for Java here is showing you the Java-based driver, which Strobe wouldn't be able to necessarily see. So it's a nice complement between these two products. So again, the key point to take away here is we were able to go through relatively quickly. We looked at the first few most used methods to look and see if we could do some performance tuning on them, and we discovered that after looking at 4 or 5 of them, that we identified that we've got a DB2, someone is using a DB2 JDBC driver rather than the native driver. And if we correct that, then we can probably drop the performance or drop the resource usage of this particular application and improve its performance and allow other applications to run more frequently. So that kind of takes us around the whole circle of what Topaz can show you today. So, and let's see, Janet, can you take me back to that slide that kind of does my summary here? Thanks. So Topaz for Java Performance has these key advantages. Again, as Steve mentioned earlier on, it runs on the specialty engine. But I'd like to also give you a warning that your applications, you need to really watch this specialty engine execution processing, because IBM has a couple JDKs or a couple JVMs that actually don't do this quite correctly, and there's some PTFs that need to be applied so that your applications and our monitor actually performs on that specialty engine. And that can be as much as 10 to 12% spillover onto your general CPU. So that's one thing I wanted to kind of point out to folks. The other thing I wanted to point out is, again, this inside versus outside view with Strobe. Strobe does a great job of showing you the job of the JVM and kind of the ZOS-based metrics that you can collect, versus Topaz for Java shows you inside of the JVM. One thing that we didn't really show, and I think is also important to talk about, is you may have JVMs all over your enterprise, and we provide a central location to actually see the performance of all those JVMs. And as Steve mentioned before, that consolidated history and data is available to you all of the time. And one thing that I wanted to point out is that we've got our initial release was supporting Java Batch and WebSphere, and we're in the process of releasing our updated version of this, which will support Java under Kix. So if you're interested in working and getting a copy to do some performance monitoring of Java transactions under Kix, we'd love to talk to you. So with that, I think we are probably ready for questions. So Steve, are there any questions out there that have come in yet?
Sure. So we have a question. How does profiling in a Java batch program work?
So what you do is in the Java batch program, you would specify an agent in the JCL where you actually start up the JVM. So you do, I think there's a BPX batch type of application or a utility that you specify in your JCL, and that has a location where you can specify a Java agent as one of the JVM parameters. And so when your JVM comes up and it starts to load your batch program, it's also loading the agent, and that agent starts collecting the data, and he starts pushing. As he starts collecting the data, he also starts saving that data off so that as the batch program runs, you're actually monitoring it. And then that data gets sent back to the reporting engine so that you can view what's going on. So was there another one?
We have another question. So why Java now? We tried Java on ZOS before, and it was slow.
Well, that is a kind of a good point. And what we have seen happen with IBM over the last about 14 months, I guess, is we've seen about 8 or 9 different new updated releases or maintenance releases of IBM's JDK. So as we've been watching, we see that they have been adding performance improvements. As we mentioned, they fixed some of the issues with stuff not running on the specialty engines. They've actually come out with Java 8, which has got some special, it utilizes some of the new instructions that IBM has added to the Z13, particularly in string handling, and we think that's going to also have a pretty dramatic increase in what your Java application performance is. Another thing, again, on the Z13 with the new ZOS that runs on Z13 is they are starting to actually implement multi-threaded support on those specialty engines, and that can increase throughput by about 80%, depending on the behavior and the characteristics of your actual application. So that's a pretty exciting set of features that are going to move Java, I think, forward. So let's see. Were there another question there, Steve? So
So there's a question for garbage collection graphs. Does it show granular activities such as tenure garbage collection, global garbage collection, etc.?
Yeah, that's something we have been looking at. There's some methods that we have that we'll be able to use to gather that type of information, but that's not available in the product today.
Okay. There's also a question, can I schedule Java measurements with Topaz for Java?
I'm sorry, yeah, I should have shown that during the demo, but yes, there is a screen where you can schedule when an application, when your Java program actually comes up, or I can, if it's like for WebSphere where it's up all the time, yes, you can schedule it in a scheduling window we have, and you can schedule it kind of by an hour or an interval or whatever you want. Or you can measure for a certain period from the time it started up. So there's a couple different ways that you can do that.
Okay, there's another question. Is Topaz specifically designed for mainframes, or can it be used on other application servers like WebSphere?
So yeah, well, we have been focusing it on mainframes, and so that's where we have spent our testing effort. And we are focused on WebSphere on the mainframe. We have internally run it on other systems, in fact, but we're not really targeting for those systems yet.
That's supported on those systems.
Right. So that's something that we may consider in the future, but as Spencer was saying, that's not currently supported, with our product.
And just to add on that, so we do support WebSphere on the mainframe. That's definitely one of our target supported platforms. But again, being a vendor that's focused on providing the best mainframe support tools, we are focused on mainframe for our Topaz solution. So there's another question. Does this provide any recommendations on what can be optimized?
Well, again, this will go and show you which threads are having issues with block things, but it really is still up to you to determine where those shared resources are that would need to be fixed for your application. So we have talked about a Topaz for Java Advisor similar to the Strobe Adviser. That's not currently. We've got that as a backlog item, but that's currently not scheduled at this point in time. However, when I say that, we are actively interested in feedback like that. If that is something that you think is a necessary for the product, we definitely want to invite you to give us a call and talk to us about kind of the feature sets that you think are absolutely required, and those things we can get on our roadmap and get out to you so that have those things available to you. One of the things that we have been doing lately is that we have changed our development process a bit so that we do quarterly releases. And as we do these quarterly releases, we found that we can get new functionality in our customers' hands much faster than we could before. So we're pretty excited about that aspect of it too.
Okay, we have time for one more question. Do you have any suggestions on how I would do a performance comparison in Topaz?
So,
and I'm sorry, it's a little beyond it. There's a little more to that. So specifically, the question is regarding comparing a COBOL program to a Java program.
Yeah. Well, we've had a couple customers tell us that they've kind of done a direct comparison between a COBOL program and a Java program simply by rewriting one of their smaller COBOL programs in Java. And what they also pointed out to us is they used our program analytics tool that's part of Topaz to kind of figure out what the bottommost or the COBOL program that was last called in one of their applications, because that made it easy for them to swap between the Java program and the COBOL program. So that was a nice way that they could do a direct comparison. It didn't require them to rewrite hundreds of their programs So I thought that was a pretty clever way for them to do it by using the analytics thing that we have and basically figuring out which COBOL application is independent of almost all others.
Okay, and this will really be our last question. So the question is, can I watch Java under CICS?
Yeah, as I mentioned, we are in the process of getting that ready to go. So we're actively looking for customers to help us do like an early adoption of that, and we think that's ready to go, and we're just waiting on someone to give us a call and set up a proof of concept of that.
We apologize if we were unable to get to all the questions today. However, we will reach out directly follow up with you after this broadcast with the answers to those questions. In the meantime, again, we'd like to encourage you to fill out the short survey after the broadcast to be entered into our $50 American Express gift card drawing. And with that, we'd like to thank you for attending today's webcast, and this concludes today's presentation. Enjoy your day.